Welcome to The Explainer. Today, we're going to follow the incredible journey of a single breath. It's something you do thousands of times a day, probably without a second thought, but we're going to trace its path from the outside world all the way to the very cells that it powers.
Because it's so much more than just moving air in and out, right? It's this super sophisticated, multi-stage process that is absolutely fundamental to your existence, powering every single cell in your body. So how does it all work?
Okay, so to really get this, you've got to think of it like a three-part mission. First up, you have external respiration. That's just getting oxygen from the air into your blood. Then that oxygen gets transported all over your body. And finally, in cellular respiration, your cells use that oxygen to create the energy that, well, keeps you alive.
All right, let's dive in. We're going to follow a single molecule of oxygen on its incredible trip into your body. And the very first part of its journey is through the system's amazing air purification and conditioning plant, the upper respiratory tract. So it all starts right here, in the upper respiratory tract. This is a whole series of passages, your nasal cavity, your pharynx, and they're all specifically designed to prepare the air for your much more delicate lungs. You can think of it as the gatekeeper for the whole system. Now, your nasal cavity, it's not just some empty cave on your face. Check out these crazy folded structures, the turbulates. What they do is they dramatically increase the surface area inside your nose, turning it into this world-class air conditioner. It warms, humidifies, and filters every breath you take, so it's perfect for your lungs. And here's where things get really clever. Your respiratory system and your digestive system actually intercept at the pharynx. So how do you not choke all the time? Well, you've got this brilliant little valve system. When you swallow, the epiglottis acts like the traffic cop of your throat, slamming shut over the airway to make sure food goes down the right pipe.
Okay, so once our little oxygen molecule gets past that intersection, it enters the larynx. You can see it right there sitting at the top of the windpipe, or trachea. And this thing has two absolutely crucial jobs for us. Job number one is pretty straightforward. It lets air pass through. But it's the second role that's so cool. This is your voice box. See, when you're quiet, your vocal cords are open, just like on the right. But the moment you want to speak, bam, they snap together like you see on the left, and the air you breathe out makes them vibrate to create sound. All right, we're moving on to the next stage of the journey. The air is now warmed up, it's clean, it's past the voice box, and now it's time for the deep dive. From that single large windpipe into a massive branching network deep inside your lungs. That main windpipe, the trachea, splits into what we call the bronchial tree, and it follows this really simple but super powerful pattern. One tube splits into two, those two split into another two, and this just keeps going like the branches of a tree for an incredible 22 levels of division. And what's the result of all that splitting? You end up with an absolutely astonishing 4 million tiny branches deep inside your lungs. 4 million. It's this massive network designed to get air to every single nook and cranny of your lung tissue. So you might be wondering, with 4 million branches, how does this place stay clean? Well, it's lined with this, a microscopic, self-cleaning escalator. These are cilia, tiny little hairs that are constantly beating in sync, pushing mucus and all the gunk it's trapped up and out of your lungs. It's pretty amazing. Okay, we've followed the air all the way down, through millions of tiny tunnels to its final destination. We've reached the main event. This is what the entire journey has been for, the Great Gas Exchange. At the very, very end of those 4 million branches, you find these tiny little air sacs called alveoli. You can see here they kind of look like a bunch of grapes, right? Well, these are the functional units of the lungs. This is where the real magic happens. And how many of these little guys do you have? Get this, about 400 million of them are packed into your lungs. I mean, it's a number that's almost impossible to even picture. So what's the point of having 400 million of them? Well, it's all about surface area. When you add it all up, their combined surface area is massive, up to 150 square meters. To give you an idea, that's about the size of a large living room, all folded up neatly inside your chest. Just incredible. And this is why you need all that surface area. Right here in the alveoli, oxygen just diffuses across this incredibly thin barrier. We're talking just 2 cells thick, and jumps right into the bloodstream. At the exact same time, the waste product, carbon dioxide, moves out of the blood so you can breathe it out. And you can see just how efficient this whole exchange is by looking at the numbers. Look at this. The air we breathe in is almost 21% oxygen and has basically no carbon dioxide.
But the air we breathe out, a big chunk of that oxygen is gone and it's been replaced with a whole lot of CO2. A perfect swap. Okay, but wait a minute. How does all this air actually move in and out? Here's a key thing to remember. Your lungs themselves have zero muscle. They're totally passive, kind of like balloons. They rely completely on a powerful mechanical pump to do all the work.
And here is that pump in action. It's actually a really simple but powerful idea. To breathe in, your diaphragm, that big muscle at the base of your chest, it contracts and flattens out. At the same time, your rib muscles pull your rib cage up and out. All this makes your chest bigger, creating a vacuum that just sucks air in. And breathing out, usually that's just relaxing. The muscles chill out, the chest gets smaller, and the air is pushed out. Simple as that.
So this entire super intricate process, it happens, 12 to 15 times every single minute. And you don't even have to think about it, right? It's on complete autopilot. So the big final question is, who's flying the plane?
Well, the answer lies deep in your brainstem, in this little region called the respiratory center. This small cluster of neurons is your body's amazing, tireless, breathing autopilot. It manages the whole show for you 24/7. Inside this center, you have these specialized pacemaker neurons. They just generate a basic rhythm, firing off automatically about once every 5 seconds or so to tell you to take a breath. And on top of that, they're constantly getting feedback from your lungs and your blood to automatically tweak the rate and depth of your breathing so it always perfectly matches what your body needs. And there you have it, the incredible journey of a single breath. It's this unconscious, perfectly orchestrated symphony of mechanics, chemistry, and neurology. I mean, think about it. You can try to hold your breath, but you can't hold it forever. And that tells you everything about the power of this vital, unconscious drive. That little autopilot deep in your brain, it will always, always win, making sure this essential journey continues, breath after breath, keeping you alive.